Suppose we have a data set that consists of the numbers 2, 3, 4, 5, 6, 7, and 8. And what we would like to do is find the average for this data set. Well, when we talk about the average, what we're usually talking about is the mean. The term that we use in statistics is the mean, and that mean has a formula. And that formula is just to add up all of the data values and then divide by the number of data values. Well, we have a way to abbreviate all of that. And if we are working with a population set of data, we would abbreviate the mean with the symbol mu. We would abbreviate the concept of adding all of the data values by using the symbol sigma, which means sum, or add up, the x values, and x is our variable, which would represent our data values. So here we have all of our x values, the values in the data set. And then the number of data values would be the size of our population if our data comes from a population. If our data is a sample, represents the data that was gathered with a sample, then the symbol for the mean is x bar. We're still going to add up the values in the sample, and we would use a little n, a lowercase n, for sample size. So large N for population size, small n for sample size, mu for population mean, and x bar for sample mean. But either way, whether this is a population set of data or a sample set of data, this mean is going to be calculated by adding these things up. 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, and then dividing by the number of data values in the data set, which is 7. So this sum then turns out to be 35 and when we divide that by 7, we're going to come up with 5. So this mean then would be 5. Let's take another set of data. Let's suppose we have the data set 2, 3, 4, 5, 6, 7, and 9. Okay, the mean then, whether it's a population or a sample, doesn't matter. The process is still the same. Add the data values, 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 9, and then divide that by the number of data values. There are still 7 data values. This is going to be 36 divided by 7. Which is going to give us 5.142857 out to that many decimal places. And so this brings up a question: how far should we round the mean? Well, we first need to talk about the general rounding rule. Many times when we are calculating measures for a data set, there will be intermediate steps. We'll calculate something and then we'll need to calculate something else and on until finally we wind up with the final calculation that needed to be made. Well, the general rounding rule is that you should not, so do not round until the final calculation has been made. Okay, well, our final calculation has been made here, so we need to come up with an actual rounding rule for the mean. And that rule is going to be to round to one more decimal place than occurs in the raw data. So when we look at our raw data values, they're all whole numbers. So our mean then should actually then be rounded to the tenths place. And the purpose for this then, here it is, 5.1, if we round to the tenths place. One of the purposes for this is to convey to the reader what the measurement precision of the data set is. If we see a mean that is rounded to tenths place, then we know that the data values must have been whole numbers. Which then tells us that even though 35 over 7 is 5, we really should report this mean as 5.0. Our mean is rounded to the tenths place, and it conveys that our data set consisted of whole numbers.